Let's get to work on the camera class. The camera is actually going to exist in 3 dimensions. And the reason for that is we want to create a zoom effect. And I can draw a little bit of what that's going to look like. Let's say we're looking at our scene from the side. So if this is the screen that we're looking at, we want to place the camera at positions out in front of the screen. And it'll be looking onto the scene, something like this, in which case this much of the scene would be visible. But we want to have the ability to now move the camera closer or farther away from the scene. In essence, we're just moving the camera forward towards the screen or backwards away from the screen, and that'll give us a zoom effect, which will show us either more detailed close-up view of the scene, or we can pull it back and then see a less detailed view but more of what's happening. Back in the code, under the graphics folder, let's create a new class. This is going to be the camera. And I'm just going to make this a sealed class. Let's bring in the MonoGame namespaces like normal. The first field I'm going to want to create for this camera is going to be a position. And that'll just be a 2-dimensional thing. So it'll tell us what part of the world we're looking straight at. So if our position is 0, 0, that means our camera is focusing straight at the origin. But we're also going to have one more variable, floating point, that'll be our z-coordinate. The z-coordinate will tell us how far from the screen are we currently positioned. I want to have one more thing. I'm going to call this the BaseZ Position. And the BaseZ Position is kind of an interesting idea. The BaseZ will tell us where do we need to position the camera so we see exactly the number of pixels as the screen resolution has. Let's say this is our screen on the side view. We're going to say it has a height of 480 pixels. So now the question is, how far this way do I need to position the camera so I can see exactly 480 pixels? Now I could move the camera in and I would see less than that in the view, or I could move the camera out and I would see more than that, but I want to know the exact point where I would see 480 pixels of height on the screen. Okay, next I'm going to need to record the aspect ratio. That's simply going to be the aspect ratio of our screen. So we're going to pass the screen into the constructor as an argument so that we can just get the aspect ratio. And then we want to know the field of view. And this is the vertical field of view that we're talking about. Looking on the side here, let me draw another one. So here's a side view of the screen. And the camera's over here. If this is the camera, I want to know what this angle is right here. And what this angle is the field of view. Okay, the FOV, but it's the vertical field of view. Next we need to set up the matrices that will transform our view from 3D space onto our screen. We have the view matrix, and then we're going to have a projection matrix. Up here I'm going to create some constant values. This is where we're going to record what the minimum Z position and the maximum Z position that is available for the camera. This will be min Z, and I'm just going to make that 1. And then we're going to have the max Z, and we'll just make that 2048. Nice power of 2 there. There we go. And that all looks good for the starting point. Let's create the constructor. Here we need to pass in the screen. Let's just do a quick check for null on the screen. Now let's set up the position. We're just going to place it at 0 to begin. Let's get the base Z, and then the actual Z coordinate. To start, we're going to set the camera's Z coordinate at the base Z. So we're going to have to actually create a function that's going to calculate the base Z, and we'll talk about what that looks like here in just a second. To initialize Z, we're always going to initialize Z to start at the base Z coordinate. What you're looking at is going to be exactly equal to the number of pixels that the screen has, okay, as far as the height goes. And I'm going to switch these positions here. Next, the aspect ratio. That'll just be the screen width divided by the screen height. And let's make sure it knows that we want this to be a floating point value. and then the field of view. This is simply going to be 90 degrees, and we can bring in the math helper, and we're just going to say pi over 2. The view and projection matrices, I'm going to create a separate function that's going to update those, because we're going to have to do it multiple times. But let's go ahead and make an update matrices, and we're going to take the view matrix, and that'll be equal to a look at, create look at matrix. Camera position, so we'll have a new vector 3, that's going to be 0, 0, and then the Z position. The reason I'm not actually putting in this position here, because we're going to manually transform any entities that we have into camera space using this position here. So before we draw anything, we'll just subtract the camera position from whatever entity we're drawing. We'll subtract the camera position, and that'll move it into camera world space, and then from there we can do the other transformations. And so the camera itself will always be pointing at 0. The only thing that's going to change is the Z position, which is going to give us that zoom effect. Next, the target is going to be the origin, so we're just going to say vector 3, 0, and the up position is just going to be vector 3 up, which is y is 1. The projection matrix is going to be a perspective field of view. The field of view we calculated earlier, so we'll do that one. The aspect ratio we also calculated earlier. And the near plane and far plane are just going to be our min and max z. Let's pass those in, the min z and the max z. And from the constructor we'll just call update matrices. That should have everything initialized except for the base z coordinate, which is what we'll talk about now. Now that we have this function update matrices, we can update these matrices anytime we have any kind of zoom effect or we need to move the camera in and out from the screen. We can call this function and update the matrices. On to calculating the base z coordinate. This is going to require a little bit of trigonometry. Let's take a look at our picture from the side view again. Let's go ahead and draw another picture here. Here's the side view of our screen. Here is the view from the camera. Here is the angle, which is our vertical field of view. And now I want to know what is this distance right here so that I get exactly the screen height number of pixels in my view. If you look at this, it's just a right triangle. Right here we end up with a right triangle. And we have everything we need to know to figure out what this value is here. And I'm going to just put z here. So we can pretty much just disregard this bottom half here. And let's start talking about the half height. So here's the half height from here to here. This angle is now going to be the 1/2 field of view. And in Trig, we have certain properties of right triangles that allow us to figure out what this piece is over here. The equation is a tangent property, which says that the tangent of an angle is equal to the opposite side on a right triangle, the opposite side to the angle, which is this 1/2 height, divided by the adjacent side, which is this z side here. Okay, so we can put z in there. If we solve for z, we're going to end up with z is equal to 1/2 height divided by the tangent, and instead of putting this Greek letter in there, I'm going to put the 1/2 field of view, which is what the angle we're using. So that'll then be the 1/2 FOV. So now we can take in a height and figure out what our base z value will be for that height. So back in our code, we're going to create a function, and this function is going to return a z value. And I'm going to call it get z from height, where we can place the height in here. And this will take a height value, which is this here, and tell us where we need to place our camera to get exactly that number of pixels in our view. Well, let's go ahead and do this. Bring this over here so I can see the equation. The z is going to be equal to 1/2, or 0.5, times the height, divided by the tangent of half, or 0.5, times the vertical field of view, which is the field of view. Okay, so now that we have that written out, let's go ahead and then we're just going to go ahead and return that z value. And instead of doing that, let's just return what we have right here. Now we can calculate the base z by using that function. We'll say get z from height, and we're going to place in the height we want, which is just the screen height. So there's the beginnings of the camera class. I just need to now allow the user to have access to these fields, so I'm just going to type these in real quick. So the position, the z position, okay, perfect. So now we have properties that will give access to all of these private values. I want one more function. Let's have a way of moving the z component. Let's do a move z, and we'll just pass in an amount. And then all we're going to say is that z is going to be incremented by the amount that's passed in. But then we also need to clamp the z by our min and max allowed values here. Let's call the utility function and say z is going to be equal to is going to be clamped by the min and the max. Okay, so that should give us everything we need to at least have a basic camera class that we can test and zoom in and out. Let's go back to the game class. What do we have in here now? Okay, so we have the sprite being drawn. I am actually going to now draw this sprite a little bit differently. So we have the texture there. Let's go ahead and do the whole source rectangle. But now I'm going to use the origin because I'm going to transform this sprite, and I want the transformation to happen right at the center of the sprite. And the sprite's 16 by 16, so the origin of transformation is going to be 8 by 8 because it's going to be right in the center. Position, let's just place it at 0 for now, so it's going to be at the origin. Rotation, I'm going to rotate it very slightly, so let's just say math. We're going to do 2 pi, and we're going to divide that by 100, so it's just a very slight rotation. And then the scale, I want it to be, let's make it twice as large. And that should be, oh, it wants a vector 2 there, so we'll do a... So let's go ahead and draw this. Everything should be the same as before, except for now the sprite is going to be, it's going to be kind of in the bottom left-hand corner. If you look down here, that's where it is right now. And that's where the origin is in screen space. But now I'm going to start moving things into camera space. And in camera space, the origin is going to be right in the middle of the screen. When we start drawing in camera space, we're going to have a view that looks like this, and instead of this being 0, 0 down here, 0, 0 is now going to be right in the middle of the screen. Let's go back here to our game class. In the sprite batcher, I'm going to change the begin function, and we're going to allow it to take a camera. We're basically going to have two different ways of drawing things, okay? If the camera is null, it's going to draw everything just like we were doing before. It's just all going to be in screen space. If the camera is not null, then we're going to start drawing in camera space, which gives us that three-dimensional zoom effect. Let's do a check. If the camera's null, we're going to keep it like the same as it was. But if the camera's not null, then we need to tell it the view and projection matrices to use. So the effect will then use, for the view, camera view, and then the projection will be the camera projection. So let's go back into our game. It's looking for a camera, so we need to create that. So let's have a camera. We will create the camera. It wants the screen. And then finally we will pass in the camera. As far as the size of the image, we shouldn't see a lot of difference. The big difference is that now the image or the sprite is going to be right in the middle of the screen. So let's see how that looks. Oh, it's giving us errors, so let's find out what we're looking for. Oh, so we use the sprite batching class to present the scene when we're done, and we want that to happen in screen space, so we're just going to pass null for the camera here. And so let's go back and try this again. And that did not work, so let's go back and find out why that's not working. Let's go ahead and debug through this. So camera is going to be null. Oh, we need to set the view in here to now be the identity. So let's try that. Okay, we don't need to pause there anymore. There we go. That looks like it's working, except for we're not actually seeing the sprite anymore. So let's go ahead and step through the begin, see if we can find out where the bug is in the code. Okay, so we're going to step into the begin function. We're going to check. One thing we need to do, I'm not sure if this is going to correct the problem, but we do need to update the camera matrices every time we want to start using them to draw. So I'm going to place that here, and then I'm going to put a breakpoint here just to see what happens. Make sure all the values that we have are correct. So there we are there. Let's go ahead and continue to the next breakpoint. We're going to go into the update matrices, and let's just make sure all of our values are good. So z, well, it's showing z is infinity, so that could be a problem. What do we have for the field of view? And those numbers look right. So let's find out why z is showing up as infinity. It's probably back in the constructor here, and oh, I can basically tell you why. So in this function, get z from height, we're using the field of view, but we actually haven't, we populate the field of view over here after we call that function. We need to move these values up above so they're populated before we call that function. I think that will correct everything. Let's go ahead and run that. And we can get rid of this breakpoint, and let's just see if we get what we're looking for. Okay, perfect. That looks exactly like what we wanted. So I'm drawing our sprite right in the middle of the screen. It's got a slight rotation on him, and next thing we want to do is actually test the zoom feature. So I want to be able to zoom in and out. Back in our game class, let's go ahead and put some, so let's go ahead and use this one here. We're going to do is key down, and I'm going to use the A key as a zoom in key, and I'm going to use the, well, let's put that one in first. So let us, if we press A, we're going to zoom in. We're going to tell the camera that we want to move Z by a negative amount. We'll just say -1 for now, just to put a value in there, see what it looks like. And let's do Z as a zoom out, and that'll be a +1. Since the 0 plane is where we're actually drawing everything, positive Z is going to come out of the screen this way. So as we increment Z, we're actually getting farther away from the screen. A is going to be zooming in. We're going to get -Z values. We're going to decrement Z, and we're going to increment Z on using the Z button. I think that should be enough to give us that zoom feature. Let's see if it works. There we go. And you can see I am zooming in and out of the scene just by pressing the A and Z keys. And interestingly enough, let's add, maybe we can add a few more things to the scene. We can add support to the shape batch for this too. So in the begin function for the shape batch, we want to do the same thing we did in the sprite batching class. So let's bring this over here. We can pretty much just copy this. Let's copy what we did over here and just put it right in the shape batching class. And just make sure everything's the same. That looks the same. So yeah, let's just get rid of that code. Let's allow it to pass in a camera class. So now if the camera's null again, we're going to use just the screen space. If it's not null, we'll update the matrices, and then we're going to use those to draw our three-dimensional camera and get our nice zoom effect. Back to the game class, let's go ahead and pass in the camera. And now let's just start drawing some rectangles. And I guess we have lines as well. Alright, let's try some, first we'll draw a rectangle. We're going to just place it to the right a little bit, so the X is going to be, say, 32. We'll put it at 0, and we're going to make it 32 by, well, let's change it a little bit, so 23 by 47, and the color is going to be a, let's just do a dark olive green. And then let's also draw a line. And where can we put this line? We'll put this line on the left side, so let's start at like a -24 and 0. And then we're going to go to, let's go up and to the right. The other end of the line is going to be at, let's do a positive number, so we'll be like 15, 33. Thickness, we'll make it relatively thick. Let's do a 3, and then the color is going to be, let's do a dark green. Now we have a couple other items in the scene, and we're using the camera to draw in camera space. Okay, so there's our scene. We should be able to move in and out and get a nice smooth zoom feature. And that looks really good. It looks really good. You can see we're zooming in on our line, and you can see the actual rectangle shape of the line there. It's kind of an oriented rectangle. I did give it a depth or a thickness of 3. And we can zoom way out as well, and that looks really good. Okay, so that's the beginnings of the camera class. Let's change this. I wonder if I change this to 10. It should be like a really fast zoom at this point. Yeah, so we're zooming. Okay, so there's us at a zoom of 1. It's clamping us to 1, but we're so close to that sprite that all we can see is white. And then here's our max zoom. Let's see if it stops us. Yeah, there's our max zoom of 2048. So we have a lot of room to play with. There's the beginnings of our camera. We'll have a few more things we want to put in there. For the most part, that's our zoomable camera.